Okay, let's do another example. This time we might not get any solution. Let's check it out. Okay, here it is. Inspect the direction of the normals. 1, -1, 1. None of them are parallel. Okay, so it's not gonna be, we're not gonna have any parallel planes or coincident planes. Okay, let's put this in a matrix. 1, -1, 1, -1, 1, 1, 1, 2, 2, 1, -5, -1, 1. Okay, the goal is to make those three values 0. Okay, all right, so 1, -1, 1, 1. Let's get row 1 and subtract row 2 and put the result here. So subtract, 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 subtract. Let's do that again for row 1 with row 3. Subtract, 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 subtract. Nice. Okay. And then the goal is not to make that into 0. So you get maybe 2 times row 2, and then we just add row 3. Okay, and don't touch anything else. Okay. Okay, double and add, right? Double and add is 0. Double and add is 0, right? And then we get double and add, and we just get -2. Okay, algebraically now, we get 0z equals -2. Now, is there a z value we can put in there so that this is true? Clearly, there's no solution here. There's no such z, no solution. Okay, so algebraically, there's no solution. So how? Why is there no solution? Okay, so most likely, what we're dealing here is this. We have a plane, and we have another plane, and we have another plane, like this. Okay, like that. And the normals are all going to be on the same plane. Okay, and they don't have a single point that's shared because these are all like the directions here. So if you look at it from the side view completely, it will look literally like this, like that. That's a plane, that's a plane, that's a plane. Okay, so they don't share any common point. If it wasn't perfectly like this, they would actually look more, like this, right? So, okay, or maybe like right now, it's like there's a big hole there. If it was a little bit tilted, so that it looks more like this, they will converge. Somewhere here, there'll be like an intersection point between the three planes, like that, okay? Only if it's like this, it wouldn't intersect. They wouldn't have any common point. Okay, so to verify that, right? If it is true that it is this scenario, okay? The normals must be doing this. The normals themselves must be doing this. They must be all on the same plane. So if you do cross product between these two and you get a vector that's perpendicular to both, it must be also perpendicular to the third one. So then if you do a dot product with the third one, it should be 0. So let's see if that is the case. Okay, that's what we're going to do here. So let's do the normal between the first two, the cross product between the first normal and the second normal, okay? And that's going to be -2, -2, -1. And then it's going to be minus of 2, -1, okay? And then it's going to be 1 plus 1, 1 plus 1, okay? So -3, and that's -1 and 2. Okay. Okay, finally, for the moment of truth, if we're right, if we dot it with normal 3, so 1, -5, and -1, it should be 0. So you get -3 plus 5 minus 2. Yes. It gave us 0. So, therefore, it's in this triangular prism configuration. Okay? All right, that's it for this one. I'll see you in the next.